Picture a night sky so vast and brilliant that it feels alive. Every star a whisper from the gods. Every constellation a story waiting to be told. This was the universe as the ancients knew it, not a distant, indifferent expanse, but a realm pulsing with meaning, where the boundaries between science and myth blurred into something extraordinary. Long before telescopes or satellites, civilizations across the globe gazed upward and saw more than just points of light. They saw a cosmic blueprint, a divine narrative etched into the heavens. And what they imagined was far stranger, far more magnificent than anything we might expect. From the pyramids of Egypt to the temples of Mesopotamia, from the observatories of the Maya to the philosophers of Greece, humanity's earliest stargazers didn't just observe the cosmos, they dreamed it into being, crafting visions of reality that still leave us breathless today. Think about it. How could cultures separated by oceans and millennia, with no shared language or technology, all arrive at the same startling conclusion that the universe was alive, purposeful, even sacred? The answer lies in something deeper than astronomy or mathematics. It's about the human instinct to seek patterns, to find stories in the chaos, to look at the stars and feel something stir within us. The ancients didn't just map the heavens, they wove them into their myths, their religions, their very understanding of existence. The Egyptians saw the Milky Way as a celestial Nile flowing through the afterlife. The Maya calculated planetary cycles with precision that rivals modern computers, yet believed those cycles held the secrets of destiny. And the Greeks, they turned constellations into epic tales of heroes and monsters, as if the sky itself were a theater of the divine. This video is your invitation to step into their world, to see the cosmos through eyes unclouded by modern assumptions. We'll unravel how these civilizations conceived realms beyond our imagination, floating worlds, layered heavens, and cosmic trees connecting Earth to the stars. You'll discover how their primitive tool-stone circles, shadow clocks, and naked eye observations revealed truths about the universe that still resonate. And perhaps most astonishing of all, you'll see how their visions, though wrapped in myth, often came staggeringly close to the scientific realities we've only recently uncovered. So settle in. By the time we're done, you'll never look at the night sky the same way again, because this isn't just a story about the past. It's a reminder that the universe, in all its mystery, still has secrets to share, and that the ancients might have known it better than we ever realized. To the ancient Egyptians, the night sky was not just a spectacle, it was a sacred landscape, a mirror of the Nile itself stretched across the heavens. They called the Milky Way the winding waterway, a celestial twin to the life-giving river that nourished their civilization. But this was no ordinary river. Here, the sun god Ra embarked on his daily journey, steering his golden bark through the starry currents, battling the serpent of chaos, Apep, to ensure the sun would rise again. Every sunrise was a victory, a reaffirmation that order would prevail over darkness, and just as the Nile's floods followed predictable cycles, so too did the heavens obey divine laws, with stars and planets moving in perfect, eternal rhythms. The pyramids themselves were more than tombs, they were cosmic gateways. The pyramid texts, etched into their walls over 4,000 years ago, describe how the pharaoh's soul would climb a ladder of light to join the imperishable stars, the circumpolar constellations that never set. These stars were the undying ancestors, the divine court of Osiris, god of the afterlife. Imagine standing in the desert darkness, tracing those same stars with your fingers, knowing they were the very path a king's spirit would travel. The alignment of pyramids with celestial bodies wasn't just architectural precision. It was a sacred bond between earth and sky, a way to tether human destiny to the cosmos. What's astonishing is how their spiritual astronomy mirrored real cosmic patterns. The Milky Way's curve matched the Nile's bends so closely that navigating one meant understanding the other. The star Sirius, whose heliacal rising heralded the Nile's annual flood, was linked to the goddess Isis, whose tears were said to cause the inundation. Even their calendar, divided into 36 decan star groups that rose every 10 days, became a celestial clock, tying time itself to the movements of the gods. This wasn't superstition, it was a profound recognition that the universe spoke in cycles, and to live in harmony with those cycles was to partake in divinity. Their vision challenges our modern divide between science and spirit. While we might separate astronomy from religion, the Egyptians saw them as one. The same priests who charted the stars also performed rituals to keep the cosmos in balance. A scribe calculating the position of Venus was also honoring Hathor, the goddess of love and joy who rode that planet across the sky. In their world, every scientific observation was a prayer, every equation a hymn. And perhaps that's the most striking lesson they leave us, that understanding the universe isn't just about measuring it, it's about feeling its pulse, hearing its stories, and recognizing our small but sacred place within it. While the Egyptians saw the cosmos as a divine river, the Babylonians approached the heavens with the meticulous precision of scribes decoding a sacred text. In the dust of Mesopotamia, where the Tigris and Euphrates carved their paths through history, astronomers tracked celestial movements with a rigor that would shape humanity's understanding of the stars for millennia. Their clay tablets, etched with cuneiform script, didn't just record observations. They revealed a universe alive with intention, where the gods spoke through the dance of planets and the flicker of comets. Take the Venus tablet of Amasajuka, a 7th-century-old relic documenting the planet's movements with astonishing accuracy. To the Babylonians, Venus wasn't just a bright light, it was the goddess Ishtar, her appearances heralding wars, harvests, or the fate of kings. They noticed patterns. When Jupiter lingered near the moon, it might signal a bountiful year. When Mars blazed unusually red, empires could tremble. These weren't random guesses. By tracking cycles over generations, they uncovered planetary rhythms so reliable that their eclipse predictions, calculated using the Saros cycle, still hold up today. The real masterpiece of their cosmic vision was the Enuma Anu Enlil, 70 tablets crammed with celestial omens, a shooting star streaking eastward. That meant the gods favored the king, a halo around the moon, beware drought. To modern eyes, it might seem superstitious, but consider this. Their priests were essentially pioneering the scientific method, meticulously documenting cause and effect in the sky. They didn't separate astronomy from divination because to them, the universe was a single, interconnected conversation, one where planetary alignments were as legible as royal decrees. Then there's the Zodiac, their most enduring legacy, dividing the ecliptic into 12 equal slices, each named after constellations. They created a celestial map that's still used today. But for them, these weren't just star signs, they were divine provinces, each ruled by a god. When the sun entered Aries, it wasn't merely a seasonal shift. It was the moment Marduk, patron deity of Babylon, took the cosmic throne. Their astrology wasn't about personal horoscopes but grand, geopolitical prophecies, where the stars dictated the rise and fall of nations. What's most striking is how their blend of math and mysticism echoes in our modern cosmos. Their base 60 numeral system, invented for celestial calculations, still defines our minutes and degrees. Their belief that earthly events mirrored heavenly ones finds eerie resonance in quantum entanglements, spooky action at a distance. Even their idea of a purposeful universe aligns with today's anthropic principle, the notion that the cosmos seems fine-tuned for life. The Babylonians would have nodded knowingly. They'd always known the stars were whispering secrets. We're only just learning to listen. While Egypt and Babylon wove the stars into myth and prophecy, the Greeks did something revolutionary. They asked not just what the heavens were, but why. Picture the bustling agora of ancient Athens, where philosophers gazed upward and dared to imagine a cosmos unshackled from gods and legends, a universe that obeyed not divine whim but unbreakable laws. Anaximander, one of these pioneering thinkers, proposed something astonishing for his time, that the universe had no edge, no boundary, no beginning or end. In his vision, the infinite, what he called the apeiron, was the source of all things, a cosmic wellspring from which worlds emerged and dissolved in endless cycles. This wasn't just speculation, it was the first stirrings of theoretical cosmology, an attempt to explain existence itself through reason rather than tradition. Then came Pythagoras, who heard music in the movements of the stars. To him, the cosmos wasn't silent, it sang. Each planet, each celestial sphere, resonated with a unique harmonic tone, blending into what he called the music of the spheres. The mathematical precision of these harmonies convinced him that numbers weren't just tools but the very fabric of reality. His followers even claimed the intervals between planets matched the ratios of musical scales, turning the night sky into a grand celestial symphony. While we now know the math doesn't hold up, the core idea that the universe operates by mathematical rules was a leap toward modern physics. Aristotle, ever the systematizer, took these ideas and built an empire of thought. His geocentric model, with Earth nested like an onion within 55 crystalline spheres, became dogma for centuries, but even here there was genius. He argued the stars were fixed to a distant outer sphere, their unchanging patterns proof of a universe both orderly and eternal. His meticulous observations of lunar eclipses noting Earth's shadow was always round led him to conclude our planet was a sphere, not a flat disk. For all its flaws, his model was the first comprehensive attempt to explain celestial motion through physics, not myth. Yet no Greek thinker was more startlingly modern than Democritus. While others imagined a single, tidy cosmos, he proposed a universe teeming with infinite worlds, each born from the random collisions of atoms in the void. Nothing exists except atoms and empty space, he declared 2,000 years before quantum theory. His multiverse wasn't just philosophical musing, it was a radical departure from the idea of a singular, Earth-centered creation. Had history listened harder to him, our scientific revolution might have come centuries sooner. What united these visionaries was their fearless blending of observation and imagination. They mapped the stars not just to navigate or prophecy, but to uncover the fundamental nature of reality. Their tools were simple naked eyes, rudimentary geometry, and relentless curiosity. But their questions were as profound as any asked by modern astrophysicists. In their pursuit, they laid the foundations of the scientific method, proving that the universe, no matter how vast, could be understood by the human mind. And perhaps that's their greatest legacy, not the answers they found, but the audacity to keep asking. The Maya didn't just measure time, they danced with it, weaving celestial cycles into the very fabric of their existence. Imagine standing atop a pyramid in Tikal, the jungle stretching endlessly below, as priests charted the slow arc of Venus across the heavens. To them, this wasn't just a planet, it was Kukulkan, the feathered serpent god, whose movements dictated war and peace, famine and abundance. Their long-count calendar, stretching over 5,000 years, wasn't a mere tally of days but a sacred map of cosmic recurrence, where history itself pulsed in rhythmic echoes. Every 52 years, they held the new fire ceremony, extinguishing all flames to relight them as the Pleiades crossed the zenith, symbolizing the universe's rebirth. Time wasn't linear, it was a spiral, looping back on itself in patterns as predictable as the tides. Their astronomical precision still stuns modern scholars. Without telescopes, they calculated the solar year to within minutes, tracked lunar eclipses with near-perfect accuracy, and even documented the retrograde motion of Mars. The Dresden Codex, a bark paper book surviving centuries of humidity and conquest, contains tables predicting Venus's appearances down to the day, a feat requiring generations of unbroken observation. But here's what's truly remarkable. They achieved this not through cold calculation, but by viewing numbers as living entities. The number 13 wasn't just a digit, it represented the layers of heaven. 20 wasn't a base for counting, it was the sacred fingers and toes of the human form. Mathematics wasn't separate from spirituality, it was the language the gods used to speak through the stars. Their cosmos was a vast, layered realm, 9 underworlds, 13 heavens, and the earthly plane suspended between them like a hammock. The Milky Way wasn't just a band of light, it was the world tree, its roots in Xibalba, the underworld, and its branches cradling the souls of ancestors. When the sun set, it didn't vanish, it traveled through the dark realms, battling monsters to emerge reborn at dawn. An eclipse, that was the celestial jaguar devouring the sun, a moment so perilous that pregnant women hid indoors, lest their unborn children inherit the beast's wrath. Even their ball game, played in stone courts across the empire, mirrored this cosmic struggle, the rubber ball's arc symbolizing the sun's journey, the victors ensuring the gods' favor for another cycle. What's haunting is how their prophecies echoed reality. The Popol Vuh, their creation epic, warned of epochs ending in cataclysm, a notion mirrored in their calendar's much misunderstood end date in 2012. Modern panic aside, they weren't predicting doom but transformation, the closing of one cycle and the birth of another, and in a way, they were right. The collapse of their classical cities coincided with devastating droughts, events their astronomy might have foreseen in shifting rainfall patterns tied to planetary alignments. Their priests didn't just read the stars, they listened to them, hearing whispers of change long before the first crop failed. This fusion of science and prophecy offers a lesson we've only begun to relearn, that the universe speaks in patterns, and ignoring those rhythms comes at our peril. The Maya didn't separate the astronomer from the priest because to understand the cosmos was to commune with it. Their legacy isn't just in carved stelae or crumbling observatories, it's in the radical idea that time isn't something we master, but something we move with, a current both ancient and endless, carrying us toward horizons they once mapped in starlight. Long before modern physics grappled with the idea of an expanding universe, the sages of ancient India envisioned reality as a vast, pulsating egg, the Brahmanda breathing in and out across unfathomable eons. Within its golden shell lay not just one world but countless layers of existence, from the dense physical plane we inhabit to luminous realms where gods and enlightened beings walk. The Rigveda's famous creation hymn, the Nasadiya Sukta, captures this mystery perfectly. There was neither non-existence nor existence then. There was no realm of air, no sky beyond it. It's a description that eerily parallels modern cosmology's concept of the quantum vacuum, a state of pure potential before time and space crystallized into being. What set Vedic cosmology apart was its breathtaking scale. Time didn't tick in years but in kalpas, single days of Brahma. each lasting 4.32 billion human years. At the end of each kalpa, the universe dissolved back into its unmanifest state, only to be reborn again, like a lotus emerging from the cosmic ocean. This cyclical view wasn't mere poetry. It encoded an intuitive grasp of entropy and renewal, of systems collapsing and reforming, a notion that finds echoes in today's theories of cosmic inflation and the multiverse. Even the Purana's description of the Brahmander's expansion mirrors the Big Bang, with one key difference. To the ancients, this wasn't a one-time event but an eternal rhythm, as natural as the rising and setting of the sun. The real brilliance lay in their understanding of perception. The concept of Maya, often simplified as illusion, was far more nuanced. It suggested that the universe we experience is like a shadow theater, where the true substance of reality remains hidden behind the curtain of our senses. Just as a rope mistaken for a snake in the dark causes fear, Maya explains why we perceive separation where there's only unity, why we see solid matter instead of vibrating energy fields. Modern physics, with its wave-particle duality and holographic principle, inches toward a similar conclusion, that reality might be a kind of cosmic projection, a dance of information rather than concrete stuff. But perhaps the most striking parallel lies in their multidimensional cosmos. The Puranas describe 14 lokas, or planes of existence, stacked like layers of a celestial onion. Some, like Buloka, our earthly realm, were dense with matter. Others, like Satyaloka, existed in pure consciousness. These weren't just mythological realms, they mapped onto states of awareness, with yogis reportedly accessing higher lokas through meditation. Today's string theory posits up to 11 dimensions curled into imperceptibly small scales, while quantum physics acknowledges parallel universes. The ancients, lacking microscopes or particle accelerators, arrived at a comparable vision through introspection, proving that the universe reveals its secrets to those who look inward as well as outward. What makes Vedic cosmology so enduring isn't just its prescience but its humility. Unlike later models that placed humans at the center of creation, these texts described Earth as a mere speck in the grand design, one of countless worlds inhabited by beings at different stages of evolution. The Bhagavata Purana even speaks of infinite universes floating like bubbles in the causal ocean, each with its own Brahma governing its destiny. It's a vision that collapses the boundary between science and spirituality, reminding us that the greatest mysteries of existence might not be solved by telescopes alone, but by awakening to the cosmos within. In the quiet glow of an imperial observatory, Chinese astronomers leaned over bronze armillary spheres, tracing the paths of celestial visitors with a precision that would shape dynasties. To them, the night sky wasn't just a spectacle, it was a grand bureaucratic system mirroring their earthly empire, where stars held royal titles and planets acted as celestial ministers. The emperor himself ruled by the mandate of heaven, a divine contract that tied his authority directly to cosmic order. When a comet streaked across the sky, like the infamous Broom Star of 44 BCE, it wasn't merely an astronomical event. It was a memo from the heavens, a warning that imbalance on Earth might soon topple thrones. Their records of supernova, like the brilliant guest star of 1054 CE, remain so accurate that modern astrophysicists still reference them to study stellar remnants today. This cosmic governance operated through two profound principles, yin and yang, the dance of opposites that sustained all existence, and the five elements wood, fire, earth, metal, and water, whose interactions explained everything from seasonal changes to the rise of dynasties. Imagine a scholar official gazing at Mars glowing red in the night, interpreting its fire element as a sign to fortify city walls against summer droughts. Or consider how the moon's yin essence governed tides and women's cycles, while the sun's yang energy fueled harvests and imperial authority. Even the forbidden city's layout embodied this celestial harmony, with its north-south axis aligning to Polaris, the purple forbidden star, around which all heavens revolved. Their celestial map was a masterpiece of practical mysticism. 28 lunar mansions divided the sky like provinces, each governing a segment of the year. When the Azure Dragon constellation rose in spring, farmers knew to plant. When the Black Turtle appeared in winter, it was time to store grain. The planets weren't wanderers but assessors. Jupiter's 12-year cycle marked the earthly branches used in calendars and divination, while Saturn's 30-year orbit audited the empire's virtue. Even the stars had portfolios. The Weaver Girl and Cowherd stars, separated by the Milky Way, told a love story that timed the annual Kixi festival, when magpies supposedly formed a bridge for their reunion. What's startling is how their system anticipated modern ecological thinking. The unity of heaven and humanity. Philosophy saw nature not as a resource to exploit but as a partner in cosmic governance. When earthquakes or eclipses occurred, the emperor would issue self-criticisms, checking if his policies had disrupted celestial balance. Their astronomical surveys, like those of the great polymath Zhang Heng, who invented the first seismoscope in 132 CE, weren't just scientific pursuits, they were acts of statecraft, ensuring the rhythm of plows and stars remained synchronized. This vision reaches its zenith in the I Ching, the Book of Changes, where hexagrams composed of broken and unbroken lines, yin and yang in miniature, became a cosmic language. Scholars cast milfoil stocks to consult its wisdom, but beneath the ritual lay a profound truth. The universe spoke in patterns, and those patterns repeated from the smallest grain of sand to the grandest celestial motion. Today, as physicists explore fractal geometry and quantum entanglement, they echo an ancient Chinese conviction that the same laws weave through heaven and earth, binding all existence into a single, shimmering web. The stars weren't just lights overhead, they were the brushstrokes of a cosmic order that humanity was meant to read, respect, and ultimately reflect. To the Lakota people, the Milky Way wasn't just a scattering of stars. It was the Wannogi Thachanku, the spirit path, where the souls of the departed journeyed to the afterlife. Picture a winter night on the Great Plains, where elders pointed to that luminous band and whispered stories of ancestors walking its shimmering trail, guided by the wisdom of the star people. Every twinkling light held meaning. The Big Dipper, known as the Seven Council Fires, represented the unity of the Lakota nation, while the constellation we call Orion was the Hand constellation, its 3 stars marking the wrist of a great celestial hunter reaching across the sky. These weren't just patterns, they were maps of memory, etched into the heavens to remind the living of their place in a vast, interconnected web of existence. For the Navajo, the cosmos pulsed with sacred energy. They called the Pleiades the Dilie, the glittering home of the holy people who taught humanity the ways of harmony. When these stars rose in the autumn, it signaled the time for storytelling, a season when the veil between worlds grew thin, and lessons from the celestial realm could be heard most clearly. The night sky was their classroom, with constellations like the Horned Rattler and the first big one serving as moral compasses, teaching respect for nature and the consequences of imbalance. Even the movement of the sun and moon carried deep significance. The Navajo's Hogan dwellings, with their circular shape and east-facing doors, mirrored the cosmos itself, aligning daily life with the eternal dance of light and darkness. Further north, the Pawnee people built entire villages to mirror the heavens. Their earth lodges, arranged in precise patterns, replicated star clusters like the Corona Borealis, which they saw as the Council of Chiefs. The morning star, known as Tarawahat, was a divine messenger, its appearance heralding both agricultural cycles and spiritual renewal. Their priests kept sacred bundles containing star charts woven from animal hide, tracking celestial events with a precision that guided planting, hunting, and ceremonial life. To them, the universe was a living clock, its gears turning with the seasons, and human survival depended on reading its face correctly. What unites these traditions is their profound understanding of the sky as a participatory story, not a distant spectacle. The Zuni people of the Southwest still perform the Shalako ceremony, reenacting the journey of their ancestral Kachina spirits who descended from the Pleiades. The Inuit, beneath the swirling auroras of the Arctic, told of the walrus spirits playing a celestial game with a human skull, their laughter creating the northern lights. Even the Mayans' distant cousins, the Pueblo peoples, charted the solstices with petroglyphs that doubled as both calendars and prayers, their spiral carvings echoing the galaxy's whirl. These narratives did more than explain the stars, they encoded survival. The Blackfoot tribe's legend of the Wolf Trail, our Milky Way, warned of the consequences of greed, while the Cherokee myth of the Great Leech in the sky explained solar eclipses as moments when cosmic balance needed restoration. Oral traditions preserved not just stories but precise astronomical knowledge. The Chaco Canyon observatories, with their cryptic window alignments, prove that indigenous astronomers tracked lunar cycles centuries before telescopes existed. Their myths were scientific observations wrapped in metaphor, ensuring vital knowledge survived generations without written records. Today, as light pollution erases the stars for many, these traditions remind us of a fundamental truth: the cosmos doesn't just belong to astrophysicists. It's a library of human experience where every culture has written its own chapter in starlight. When a Navajo elder points to Scorpio and calls it the locust, or a Lakota storyteller traces the Cygnus constellation as the flying swan, they're not just naming shapes, they're keeping alive a dialogue with the universe that began when humanity first looked up and wondered. That dialogue, woven from equal parts poetry and precision, might be the most enduring lesson the stars have to teach. For the Polynesian navigators, the ocean was not an empty expanse but a sacred pathway, etched with celestial signposts only they could read. Picture a double-hulled voyaging canoe cutting through moonlit waves, its sails taut against the wind, as a master wayfinder crouches low to study the swells. With no compass or sextant, he reads the night sky like a story, each star a character, each constellation a chapter in an epic that stretches across thousands of miles. The star compass he carries in his mind divides the horizon into 32 houses, each anchored by a guiding light. Hoculaire Arcturus for the north, Ki Alii O Kona I Kalua Southern Cross for the south. But this was no sterile navigation tool. To the Polynesians, these stars were ancestors, their light a whispered invitation to follow. What's astonishing is how they perceived the cosmos as an extension of their homeland. They didn't just use the stars to find islands, they believed the islands themselves were celestial reflections. A navigator might steer toward Hawaii, the mythical homeland said to lie both beneath the waves and among the stars. The Pleiades weren't merely a cluster, they were Makali, the eyes of the gods watching over voyagers. Even the ocean currents spoke. A sudden shift in wave patterns could signal land over the horizon long before it was visible, a phenomenon modern science now attributes to the refraction of swells around distant shores. Birds became compasses too. The flight path of the Monu-o-ku white tern reliably pointed to the nearest land at dawn and dusk. Their techniques defied what Europeans once deemed impossible. While Western explorers clung to coastlines for fear of falling off the edge, Polynesians crossed the Pacific's greatest gaps, 2,000 miles of open water between Tahiti and Hawaii, with nothing but memory and observation. They memorized star paths by lying naked in tide pools for nights on end, their bodies aligned with the heavens until the sky's movements became as familiar as their own breath. They tracked the zenith stars, those that passed directly overhead, to pinpoint their latitude. When clouds obscured the sky, they navigated by the ocean's pulse, sensing islands through the way currents bent around them like invisible threads. This knowledge wasn't just practical, it was sacred. Before each voyage, navigators underwent spiritual preparation, fasting and chanting to align themselves with the cosmos. The canoe itself was a microcosm of the universe, its hulls representing the duality of earth and sky. To steer off course wasn't merely a mistake, it was a rupture in the delicate balance between humanity and nature. Perhaps that's why their voyages were so precise. They weren't conquering the ocean but conversing with it, following a celestial protocol older than any written language. The revival of this art in the 1970s, when the Hokulea canoe retraced ancient routes using only traditional methods, proved its brilliance wasn't legend but science. Modern instruments confirmed what Polynesian elders had always known, that the stars, waves, and wildlife form a living navigation system, one that doesn't just guide the body but speaks to the soul. Their legacy challenges our modern divide between intuition and intellect, reminding us that the universe, in all its vastness, might still be known not just through calculations, but through kinship. While Europe slumbered through its so-called Dark Ages, the cities of the Islamic world burned bright with intellectual fire. In the bustling observatories of Baghdad, Damascus, and Samarkand, scholars armed with newly perfected astrolabes didn't just preserve Greek and Indian astronomy, they revolutionized it. Take al-Biruni, the 11th century polymath who calculated Earth's circumference with an error margin of just 1%, using little more than trigonometry and a mountain in Afghanistan. His method was as elegant as it was ingenious. By measuring the dip of the horizon from a high peak, he deduced our planet's curvature centuries before European circumnavigations proved the Earth wasn't flat. But his genius didn't stop there. He theorized that the Indus Valley must have once been underwater, evidenced by fossils, and even pondered whether the stars might be other suns with their own orbiting worlds, a radical idea that wouldn't resurface in the West until Giordano Bruno's time. At the heart of this cosmic renaissance stood the House of Wisdom, Baghdad's legendary academy where Persian, Greek, Syriac, and Sanskrit texts mingled on crowded shelves. Here, under the patronage of caliphs, scholars like al-Sufi produced the Book of Fixed Stars, a celestial masterpiece that didn't just copy Ptolemy's star catalogue but corrected it. His meticulous observations added the first recorded mention of the Andromeda Galaxy, which he called the Little Cloud, and detailed the Large Magellanic Cloud visible from Yemen. These weren't dry academic exercises, they were acts of reverence. Many Islamic astronomers saw their work as a form of Ibra contemplation of divine creation, where every precise measurement revealed another verse in the universe's sacred text. The astrolabe, once a crude Greek instrument, became their scientific Swiss Army knife. Refined to breathtaking complexity by artisans like al-Khwarizmi, these brass marvels could tell time, calculate prayer schedules, and even determine the Qibla direction for Mecca from anywhere on Earth. But their real triumph was the Zij astronomical tables, so accurate they put Europe's calendars to shame. The Zij Isultani, compiled by Ulugh Beg in 15th century Samarkand, contained the positions of over 1,000 stars, calculated using a gargantuan sextant with a radius of 40 meters. His observatory's ruins still stand in modern Uzbekistan, its shadow once tracing the sun's path like a cosmic sundial built for giants. What set these scholars apart was their fearless speculation. Ibn al-Haytham, the father of optics, debunked Aristotle's claim that the Milky Way was an atmospheric phenomenon by proving its light remained constant regardless of atmospheric conditions. And Al-Kindi, centuries before Newton, argued that space might be filled with an invisible medium through which light propagated, a haunting precursor to the concept of the ether. Most startling of all was the 9th century thinker Al-Razi, who envisioned an infinite universe with countless worlds, writing, "The Creator is capable of creating what is beyond human comprehension." Their legacy isn't just in star charts or instruments, but in a paradigm shift, the idea that the cosmos obeyed consistent, discoverable laws. When Copernicus cited Islamic astronomers in his revolutionary work, he wasn't being polite. He was standing on the shoulders of giants who'd kept the flame of inquiry alive. The next time you glance at a star map or check a weather app, remember, behind those pixels lie 1,000 years of careful observation, from the deserts of Arabia to the marble halls of Cordoba, where scholars once looked up and saw not just points of light, but a universe begging to be decoded. Medieval Europe's vision of the heavens was a tapestry woven from threads of ancient wisdom and divine revelation, a cosmos where science and scripture danced an uneasy waltz. Picture an illuminated manuscript, its gold leaf stars glinting against a vellum sky, each celestial sphere meticulously painted as a perfect crystalline orb. To the scholars of the 13th century, this wasn't just art, it was theology in ink. Earth sat motionless at the universe's heart, cradled by the moon's orbit, then Mercury's, Venus's, the sun's, and outward through the planets until the fixed stars marked the edge of creation. Beyond them, the primum mobile, the first moved sphere, turned by the hand of God himself. This was Aristotle's universe baptized into Christian thought, a mechanical marvel where angels guided the spheres like celestial clockmakers. Yet beneath this orderly surface, cracks were forming. Thomas Aquinas, the great synthesizer, labored to stitch Aristotle's logic to Christian doctrine, arguing that reason and faith could never truly conflict. His Summa Theologica became the medieval mind's blueprint, where planetary motions were both natural phenomena and divine poetry. But even as Aquinas wrote, whispers of dissent emerged. In the quiet libraries of Oxford, Robert Grosseteste pondered light as the first form of creation, a cosmic glue binding matter to spirit. His student, Roger Bacon, went further, insisting that mathematics, not allegory, was the key to unlocking nature's secrets. Their ideas flickered like candle flames in a vast cathedral, fragile but impossible to ignore. Then came Nicholas of Cusa, a cardinal whose thoughts soared beyond the spheres. In his unlearned ignorance, he dared to suggest that the universe had no center, or perhaps was all center, and that Earth, far from being unique, might be just another star among countless others. His reasoning was theological. An infinite God, he argued, would surely create a cosmos without edges. Though Cusa lacked proof, his vision was radical. Imagine standing in a 15th century church, gazing at a fresco of the Last Judgment with its neat tiers of heaven and hell, while someone beside you murmured that the artwork might be missing whole dimensions. The real tension lay in the heavens themselves, when comets blazed across the sky. Like the ominous star of 1572, they didn't follow the rules. These weren't atmospheric phenomena, as Aristotle claimed, but visitors from beyond the lunar sphere, their paths defying the perfect circles of Ptolemaic astronomy. Even the planets misbehaved. Mars's retrograde loops frustrated astronomers forced to invent ever more elaborate epicycles to save appearances. The tools were changing too. Astrolabes imported from Islamic lands let scholars measure star positions with new precision, while the first mechanical clocks mirrored the universe's supposed regularity. What's fascinating is how these contradictions fueled progress. The Church, often painted as science's opponent, was its unlikely midwife. Pope Gregory XIII's calendar reform in 1582 leaned on Copernican math to fix Easter's date, even as heliocentrism remained heresy. Cathedral schools became hubs of observation, where monks tracked eclipses and bishops collected meteorites. This wasn't blind faith versus cold reason. It was a civilization straining to reconcile two ways of knowing, each incomplete without the other. By the time Copernicus's On the Revolutions appeared in 1543, the medieval cosmos was already unraveling, but its legacy wasn't just error. It was a framework bold enough to be tested, a scaffold later thinkers would dismantle piece by piece. Those concentric spheres, for all their simplicity, had held a profound truth that the universe was lawful, intelligible, and worthy of study. The real revolution wasn't throwing out the old model, it was realizing that even the stars could surprise us. Nicolaus Copernicus didn't just move the Earth, he shattered the entire cosmic order. Picture the year 1543, the final hours of the astronomer's life, as his masterwork on the revolutions of the heavenly spheres emerged from the printing press. Its central claim was as simple as it was explosive. The sun, not our planet, anchored the dance of the heavens. This wasn't mere tinkering with Ptolemy's ancient model. It was an intellectual earthquake that cracked the foundations of 2,000 years of cosmology. The Church had long embraced Aristotle's nested spheres and Earth's privileged place as divine truth, but Copernicus's math revealed something startling. When you placed the sun at the center, the planet's erratic loops suddenly made sense. Retrograde motion, that perplexing zigzag of Mars through the night sky, wasn't the planet changing direction but Earth overtaking it in its orbit, like a faster runner passing a slower one on a circular track. What's often forgotten is how deeply radical this idea felt. To suggest Earth was just another planet meant stripping humanity of its cosmic centrality, a psychological blow as profound as Darwin's later revelation that we weren't separate from the animal kingdom. The backlash wasn't just theological, it defied common sense. If Earth spun at dizzying speeds, why didn't we feel it? Why didn't hurricanes rage constantly from the motion? Copernicus had no answer, and even his allies wavered. His model still clung to perfect circular orbits, requiring clunky epicycles that barely improved on Ptolemy's accuracy. Yet the seed was planted. A young mathematician named Georg Rheticus risked his reputation to champion the theory, smuggling printed proofs across Europe like contraband. By the time Galileo trained his telescope on Jupiter's moons in 1610, the old cosmology was crumbling like a sandcastle at high tide. The real revolution wasn't just in the stars, it was in how we thought about truth itself. Ancient astronomers had worked within a framework where philosophy dictated reality. If Aristotle declared the heavens perfect and unchanging, any observation to the contrary had to be forced into that mold. Copernicus flipped the script, let the math speak first, even if it contradicted tradition. His sun-centered universe was colder, vaster, and far less anthropocentric than the cozy medieval cosmos, but it held a new kind of poetry, one where harmony emerged not from dogma but from numerical elegance. Johannes Kepler, building on this foundation, would soon discover that planets moved in ellipses, not circles, guided by invisible forces we now call gravity. Each step pulled humanity further from the center, yet paradoxically deepened our understanding of the cosmic web binding us to the stars. This shift echoes beyond astronomy. The Copernican principle, the idea that we occupy no special place in the universe, now underpins modern science, from cosmology's hunt for alien life to quantum physics' insistence that reality exists independent of observers. Yet for all its austerity, the heliocentric model birthed a new wonder. If Earth was a wanderer like Venus or Jupiter, then those points of light weren't just decorations, they were worlds. That realization sparked dreams of interstellar travel, of other civilizations gazing back at our sun as their evening star. The universe, once a painted dome overhead, became an ocean waiting to be crossed. And though Copernicus himself never lived to see the tide turn, his quiet rebellion in a Polish observatory proved one timeless truth. Sometimes to see the light, you must first dare to stand in the shadows. Johannes Kepler gazed at the night sky and heard a symphony where others saw only silence. Trained in theology yet haunted by numbers, he became the unlikely bridge between ancient mysticism and modern science, a man who would trade Ptolemy's perfect circles for the messy truth of ellipses. His breakthrough came not from rejecting tradition but from listening more deeply to the data. For years, he'd wrestled with Mars's erratic motion, trying to force it into circular orbits as Greek astronomy demanded. Then, in a flash of insight, he tried an oval path. The numbers suddenly aligned with eerie precision, as if the universe had been waiting for someone bold enough to hear its true rhythm. His first law shattered 2,000 years of dogma. Planets orbit the sun in ellipses, not perfect circles. This wasn't just a geometric tweak, it upended the very idea of celestial perfection. The second law was even more startling. Planets speed up when closer to the sun and slow down when farther away, sweeping equal areas in equal times. Picture a cosmic ice skater pulling arms inward to spin faster, governed by forces no one yet understood. But it was his third law that revealed the universe's hidden music, the precise mathematical relationship between a planet's orbital period and its distance from the sun. Jupiter's 12-year orbit wasn't arbitrary. It was a note in a grand harmonic scale, predictable down to the decimal. What's often overlooked is how deeply personal this revelation was for Kepler. A devout Lutheran, he saw these laws as glimpses of God's mind. His Harmonious Mundi wasn't just a scientific treatise, but a mystical exploration of cosmic ratios, linking planetary orbits to musical intervals. To him, Mercury's high-speed orbit sang a soprano's trill, while Saturn's slow march thrummed a bass note. The planets weren't silent wanderers, they were a celestial choir, their movements composing a harmony too vast for human ears. Modern astronomers would later confirm this intuition, detecting actual sound waves pulsing through interstellar gas, proving space isn't silent after all. Kepler's genius lay in his refusal to separate beauty from truth. Where Galileo championed cold empiricism, Kepler wove poetry into his equations, convinced the universe favored elegance. His faulty optics didn't stop him from theorizing about eyeglass designs. His flawed lunar geology still envisioned alien landscapes centuries before astronauts. Even his mistakes were fertile. His attempt to nest the 5 Platonic solids between planetary orbits, though incorrect, hinted at a universe built on geometric patterns now seen in quantum foam and galaxy clusters. The real legacy of his laws wasn't just in predicting planetary positions, it was in proving the cosmos spoke mathematics. When Newton later derived gravity's force from these very laws, he stood on Kepler's shoulders. That leap from descriptive astronomy to predictive physics changed everything. No longer were the heavens governed by capricious gods, they obeyed equations anyone could test. Yet for all their precision, Kepler's laws retain a whisper of wonder, a reminder that science, at its best, doesn't diminish mystery but deepens it. The music he imagined still plays, in the hum of orbiting satellites and the silent spin of exoplanets light years away, a lullaby written in calculus and starlight. Galileo's hands trembled as he adjusted the lens of his strange new instrument, a tube of lead and glass that magnified distant objects 20 times over. What he saw that night in 1610 would tear apart the medieval cosmos forever. Jupiter, that wandering star, wasn't alone. 4 smaller lights flanked it, shifting positions night after night like loyal attendants. They weren't stars, they were moons circling another world just as our moon circled Earth. In that moment, Aristotle's perfect, unchanging heavens cracked like thin ice beneath Galileo's boots. If Jupiter had its own celestial companions, then Earth wasn't the sole center of motion. The implications were terrifying and thrilling, but it was the moon that delivered the deadlier blow to ancient dogma. Peering through his telescope, Galileo saw mountains casting jagged shadows across the lunar surface, valleys deeper than any on Earth, and vast plains pocked with craters. This wasn't the smooth, flawless sphere of Aristotelian tradition. It was a world as rugged and imperfect as our own. Even the sun, when Galileo dared to observe it, risking his eyesight with each glance, bore dark blemishes, sunspots that moved, proving the sun itself rotated. Every observation chipped away at the old cosmology, revealing a universe messy, dynamic, and utterly indifferent to human notions of perfection. Then came the Milky Way. For millennia, poets had described it as a celestial river or spilled divine milk. Galileo's telescope transformed it into something far more humbling: countless stars, packed so densely their light blurred into a luminous haze. The sky wasn't a painted dome with a few thousand pinpricks. It was bottomless, a void teeming with suns beyond numbering. This revelation struck deeper than any theological debate. If the naked eye had missed so much, what else lay hidden? The universe, once intimate and knowable, now stretched into terrifying immensity. The Church's reaction was inevitable. Scripture spoke of the sun standing still at Joshua's command. How could that be literal if Earth wasn't even the center of motion? Galileo's dialogue concerning the 2 chief world systems, which dared to present Copernicanism as more than mere hypothesis, earned him house arrest for heresy. Yet even silencing him couldn't unsee what his telescope had revealed. Jupiter's moons still orbited, the sun still turned, and the Milky Way stars refused to dissolve back into myth. What makes Galileo's legacy so enduring isn't just his defiance, it's how he redefined what it meant to see. Before him, astronomy relied on naked eye observations passed down through generations. His telescope was the first prosthetic for human perception, extending our senses beyond their natural limits. In that sense, every modern observatory, every space probe, even the James Webb Telescope's infrared eyes descend from that humble Venetian instrument. The universe hadn't changed, our ability to witness it had, and once the veil lifted, there was no going back. The stars would never seem small again. Isaac Newton sat beneath an apple tree and saw more than fruit. He glimpsed the hidden machinery of the cosmos. When that legendary apple fell, it wasn't just gravity pulling it earthward. It was the same invisible force that held the moon in orbit, that made tides rise and planets curve through space. His Principia Mathematica didn't just describe these motions, it revealed a universe governed by universal laws, where the same equations could predict a cannonball's arc or Saturn's dance around the sun. For the first time, the heavens and earth were no longer separate realms but parts of a grand, interlocking system, a clockwork cosmos where every tick and tock followed mathematical rules. Newton's laws were deceptively simple. An object in motion stays in motion unless acted upon, a radical notion in an era that still vaguely imagined Aristotle's natural rest. Forces equal mass times acceleration, meaning the same push that sends a child spinning top wobbling also steers comets along their elliptical paths. And for every action, an equal and opposite reaction. When a rocket expels flame downward, it's this law that hurls it skyward. But the real masterpiece was his law of universal gravitation. That equation force equals the gravitational constant times the product of two masses divided by the distance squared wasn't just a formula. It was a key that unlocked everything from ocean tides to the precession of equinoxes. Suddenly, the chaos of the cosmos had a blueprint. What made Newton's vision so revolutionary was its determinism. Given enough data, the position, velocity, and mass of every particle in the universe, one could theoretically calculate the entire future and past. The French mathematician Pierre-Simon Laplace later echoed this idea with his demonic thought experiment, an intellect that knew all forces and all positions could render the cosmos nothing uncertain. This wasn't just science, it was a philosophical earthquake. If the universe ran like clockwork, where did that leave free will, divine intervention? Newton himself wrestled with these questions, filling his private writings with alchemical symbols and biblical numerology, as if his own laws had left him uneasy with their cold perfection. Yet for all its precision, Newton's universe harbored paradoxes. Gravity acted instantaneously across vast distances, a spooky action at a distance that even he admitted felt absurd. Light, which his prism experiments proved was made of colors, somehow behaved both as particles and waves, and his absolute space and time, unchanging backdrops against which the cosmic drama unfolded, would later crumble under Einstein's relativity. But these weren't failures, they were doorways. Newton knew his work was incomplete, writing in a letter to fellow scientist Robert Hooke, "If I have seen further, it is by standing on the shoulders of giants." He couldn't have imagined that his clockwork cosmos, for all its elegance, was just the first movement in a far stranger symphony. The legacy of his Principia ripples through modern life in ways he'd never fathom. GPS satellites correct for relativistic time dilation using Newtonian principles as their foundation. Space missions slingshot around planets using gravity assists calculated from his laws. Even the smartphone in your pocket relies on algorithms tracing back to his calculus. Yet perhaps his greatest gift was the conviction he instilled in generations of scientists that the universe, however vast, is knowable. Not because it's simple, but because it speaks a language we can learn, the language of mathematics, written in forces and motions, waiting for the next curious mind to decipher its deeper rhythms. Albert Einstein didn't just revise Newton's laws, he rewrote the very language of reality. Picture a young patent clerk in Bern, Switzerland, daydreaming about tram rides and beams of light. While the world still saw space as a static stage and time as an unchanging rhythm, Einstein dared to ask, what if they were fluid? His theory of special relativity, born in 1905, declared that time slowed down the faster you moved, a phenomenon called time dilation. Imagine two identical clocks, one placed on a speeding rocket, the other on Earth. When the rocket returned, its clock would show less time had passed. This wasn't science fiction, it was measurable physics proven by atomic clocks on jets and even affecting GPS satellites orbiting our planet. But Einstein's real masterpiece came a decade later with general relativity. Here, gravity wasn't some mysterious force reaching across emptiness, it was the warp and weave of spacetime itself. Think of a trampoline stretched taut. Place a bowling ball in the center and the fabric dimples. Roll a marble nearby and it spirals inward, not because of some invisible pull, but because the surface beneath it is curved. Stars and planets do the same to the cosmos. When light from a distant star passes near the sun during an eclipse, it doesn't travel in a straight line, it follows the curve of warped spacetime, bending like a car driving over a hill. Astronomers confirmed this in 1919, photographing stars displaced from their expected positions, just as Einstein's math had predicted. The implications were staggering. If space could bend, then the universe wasn't just expanding. It might have a history, a beginning. Einstein's equations hinted at a cosmic explosion from an infinitely dense point, though he initially resisted the idea. His cosmological constant, a fudge factor added to keep the universe static, would later haunt him when Edwin Hubble proved galaxies were racing apart. The universe wasn't eternal and unchanging. It was dynamic, evolving, alive. Most mind-bending of all was the realization that time and space were two sides of the same fabric. A black hole's gravity, for instance, stretches time so severely that to an outside observer, a falling object would appear to freeze at the event horizon, its light redshifted into oblivion. Meanwhile, near light-speed travel could compress years into moments, a concept that fuels dreams of interstellar voyages. Ancient astronomers saw the heavens as a divine clockwork. Einstein revealed them as a cosmic trampoline, where matter and energy danced to the tune of geometry. Yet for all its strangeness, relativity touches our daily lives. Without corrections for time dilation, GPS would misplace you by miles within minutes. Particle accelerators rely on relativistic speeds to smash atoms, revealing quantum secrets. Even the humble gold's yellow shine, that's relativity, two electrons moving so fast around the nucleus that their mass increases slightly, shifting the light they absorb. Einstein's universe is wilder than Newton ever imagined, yet it hums through our phones, our maps, our very understanding of existence. The ancients sought gods in the stars. Einstein found equations, and in them, a cosmos more wondrous than myth. At the heart of an atom, reality stops playing by the rules we know. Particles wink in and out of existence. Electrons exist in multiple places at once, and the very act of looking changes what's there. This isn't science fiction, it's quantum mechanics, the study of a world so small that our everyday logic simply falls apart. When Niels Bohr and Werner Heisenberg first peered into this realm in the early 20th century, they found a universe governed not by certainty, but by probability. An electron isn't a tiny planet orbiting a nucleus. It's a cloud of possibilities, a haze of maybes that only collapses into a definite position when measured. It's as if the universe, at its core, is constantly rolling cosmic dice. What makes quantum mechanics so baffling is its defiance of classical physics. Take entanglement, a phenomenon Einstein famously dismissed as spooky action at a distance. When two particles become entangled, measuring one instantly determines the state of the other, no matter how far apart they are, even across galaxies. This isn't just faster than light communication. It's a fundamental interconnectedness that suggests space and time might be illusions, mere shadows of a deeper, hidden reality. Ancient Hindu sages spoke of Maya, the cosmic illusion that veils the true nature of existence. Quantum mechanics, in its own way, echoes this idea. What we perceive as solid and separate might be threads in a vast, invisible tapestry. The implications ripple far beyond the lab. Quantum tunneling, where particles pass through barriers they shouldn't be able to cross, explains how stars fuse hydrogen into helium. Without it, the sun wouldn't shine. Schrödinger's famous cat, simultaneously alive and dead in its box until observed, isn't just a thought experiment. It highlights how observation shapes reality itself. Some interpretations suggest that every possible quantum outcome spawns a new universe, meaning there could be infinite versions of you reading infinite versions of this sentence. The cosmos, it seems, is far stranger than even Einstein's curved spacetime predicted. Yet for all its mystery, quantum theory works with uncanny precision. Your smartphone's silicon chips rely on quantum effects to function. MRI machines image your body using the spin of entangled protons. Even photosynthesis, the process that powers plants, depends on quantum coherence to harvest light with near-perfect efficiency. The ancients imagined the universe as a living, breathing entity. Quantum mechanics hints they might have been closer to the truth than we ever guessed. At the smallest scales, the boundary between matter and energy, between observer and observed, blurs into something almost mystical. The quantum realm doesn't just challenge our understanding of physics. It invites us to wonder whether reality, at its deepest level, is less a clockwork machine and more a living, shifting dream. In the quiet static of an old television set, two astronomers found the echo of creation itself. When Arno Penzias and Robert Wilson pointed their radio telescope at the sky in 1965, they expected silence. Instead, they heard a faint hiss coming from every direction, a whisper from the dawn of time. This was the cosmic microwave background, the afterglow of the Big Bang, cooling over 13.8 billion years into microwave radiation that fills the entire universe like invisible stardust. That faint static was the smoking gun, proof that our cosmos wasn't eternal, but born in a searing flash of energy and expansion. The story of the Big Bang begins not with an explosion, but with an unfolding, a singularity, a point of infinite density where all known laws of physics break down. In that first incomprehensible moment, space itself erupted outward, carrying matter and energy like leaves on a cosmic river. Within minutes, hydrogen and helium coalesced from the cooling plasma, the raw ingredients for every star and galaxy to come. But here's what's astonishing. We can still see the fingerprints of that primordial soup. The ratios of these elements in today's universe match the predictions of Big Bang nucleosynthesis with uncanny precision, as if the universe left us a chemical signature to confirm its origin. Yet the deeper we look, the stranger the cosmos becomes. Take dark matter, the invisible glue holding galaxies together. Stars orbit their galactic centers so fast that without some unseen mass, they'd fling into the void. This phantom substance, 5 times more abundant than ordinary matter, reveals itself only through gravity's tug, like a shadow puppet moving behind a screen. Then there's dark energy, the mysterious force accelerating the universe's expansion. Imagine blowing up a balloon with dots on its surface. As it inflates, the dots move apart. Now imagine the balloon starts inflating faster over time, as if some unseen breath keeps pushing. That's our universe, stretching at speeds that defy expectation, driven by an energy we can't yet explain. The cosmic microwave background holds even more secrets. Tiny fluctuations in its temperature, variations of just 1 part in 100,000, are the blueprints for all cosmic structure. Those microscopic ripples seeded the galaxies, the filaments of the cosmic web, the vast voids between. It's as if the universe whispered its future in those first moments, and we're only now learning to translate its language. But the Big Bang raises questions as profound as the answers it provides. What sparked it? Some theories suggest a quantum fluctuation. In a pre-existing void, a bubble of space-time pinched off from a larger multiverse. Others propose cyclical universes, colliding brains in higher dimensions, or even a holographic projection from the edge of reality. The ancients imagined turtles holding up the world. We posit 11-dimensional strings vibrating in a quantum foam. Our myths have equations now, but the wonder remains the same. Perhaps the most humbling realization is this: the Big Bang wasn't an event in space, it was the origin of space itself. There was no before, because time began in that moment. No outside, because space didn't yet exist to be filled. The human mind recoils at such concepts, yet the math insists they're true. We're left staring into the abyss, not with fear, but with a quiet awe, the same awe that once made our ancestors name the stars after gods. The universe is stranger than fiction, grander than myth, and in its infinite mystery, it still calls to us across the ages. The distance between ancient stargazers and modern astronomers seems vast until you realize they were asking the same timeless questions. Consider the Maya, whose long count calendar could track celestial cycles spanning thousands of years with precision rivaling today's atomic clocks. They didn't have Hubble's lens, but their observatories at Chichen Itza, aligned to Venus's risings, proved they decoded planetary motions with nothing but shadow and stone. Or take the Greeks, who debated atoms and infinite worlds centuries before microscopes or space probes. Democritus's Multiverse and Pythagoras's musical spheres weren't mere fantasies. They were early attempts to explain patterns our equations now confirm. Even Polynesian navigators, steering by star currents and bird flights, understood oceanic highways modern GPS still follows. Their knowledge wasn't just practical, it was poetic, a reminder that science and wonder aren't opposites but partners. What's striking isn't how wrong the ancients were, but how often they glimpsed truths we've only recently verified. The Hindu concept of cyclical universes mirrors today's theories of cosmic inflation and multiverses. Aristotle's claim that Earth was round, deduced from lunar eclipses, preceded Magellan's voyages by nearly 2 millennia. And when indigenous cultures from the Lakota to the Aboriginal Australians mapped the sky as a living storybook, they anticipated modern cosmology's view of the universe as an interconnected web. These weren't lucky guesses, they were the fruits of patient observation passed down through generations like heirlooms of light. Yet there's a crucial difference. Where we see cold equations, they saw divine dialogue. The Babylonians didn't just record Venus's orbit, they interpreted it as Ishtar's love letters to humanity. Egyptian priests didn't merely chart Sirius's heliacal rising, they believed it signaled the Nile's flood and the goddess Isis's tears. This fusion of empiricism and myth might seem unscientific until you consider how modern astrophysicists speak of black holes as monsters or dark matter as the universe's scaffolding. We still personify the cosmos because its mysteries exceed sterile data. The ancients simply wore their awe more openly, weaving math and meaning into a single tapestry. Our tools have changed, but the human gaze remains the same. The James Webb Telescope's infrared eyes peer further than Babylonian ziggurats ever could, yet both reveal the same truth. The universe is vaster, stranger, and more beautiful than we imagine. When a Polynesian wayfinder steered by the star compass and a modern astronaut navigates by quantum gyroscopes, both are answering that primal urge to explore, to map the unknown. The real bridge between eras isn't technology, it's curiosity. Whether carved on clay tablets or coded in supercomputers, that relentless questioning is what propels us forward, century after century, toward the next horizon of understanding. The night sky was never silent for our ancestors, it spoke in the language of myth, where every constellation had a voice and every planet played a role in an epic celestial drama. Take the Egyptian sun god Ra, whose nightly voyage through the Duat, the underworld, wasn't just a thrilling tale of survival against the serpent Apep. It was a masterclass in astronomy, encoding the sun's disappearance at dusk and rebirth at dawn into a story so vivid that even children could grasp the mechanics of the solar cycle. The 12 hours of Ra's journey mirrored the 12 gates of the night, each guarded by deities who represented the stars marking time's passage, a narrative observatory, if you will, where myth and measurement were one and the same. Across the Mediterranean, the Greeks envisioned the heavens as a stage for their gods, but hidden within those dramas were startling insights. Atlas, condemned to hold up the sky, wasn't merely a symbol of endurance. His burden reflected an early understanding of celestial mechanics, the idea that the dome of stars required some force to keep it from crashing down. Even the tragic tale of Orion, the hunter placed among the stars after his death, preserved crucial knowledge. The constellation's seasonal disappearance and return mirrored the agricultural calendar, signaling when to plant and when to harvest. These myths weren't bedtime stories, they were mnemonic devices, turning abstract celestial patterns into unforgettable sagas that guided practical life. Nor were these connections limited to the Mediterranean. In Mesoamerica, the Maya told of the hero twins who outwitted the lords of the underworld in a ballgame that mirrored the movements of Venus. This wasn't just entertainment, it encoded the planet's precise 584-day cycle, a number meticulously recorded in the Dresden Codex. The twins' victory symbolized Venus's reappearance as the morning star, a celestial event that dictated the timing of wars and coronations. Similarly, the Norse myth of the wolf skull chasing the sun explained solar eclipses, while the Maori story of Rangi and Papa, the Sky Father and Earth Mother forcibly separated by their children, captured the primal separation of heaven and earth that echoes modern cosmology's expanding universe. What's remarkable is how these myths often converged across unconnected cultures. Dragons or serpines swallowing the sun during eclipses appear from China to the Americas, a universal metaphor for an event that terrified and fascinated in equal measure. The Pleiades star cluster was seen as a group of sisters, hunters, or seeds in traditions from Greece to indigenous Australia, proving that certain celestial patterns inspired similar human responses. These parallels suggest something profound. Mythology wasn't just a way to explain the cosmos, it was a shared cognitive toolkit, a means of transforming the chaos of the night sky into a coherent, teachable order. But perhaps the greatest power of these stories lies in their duality. They weren't just primitive science or allegorical lessons, they were both at once. When the Inuit described the aurora as ancestors playing football with a walrus skull, they blended awe at a mysterious phenomenon with keen observation, noting the light's flickering, ball-like movements. When Hindu texts described the god Vishnu dreaming the universe into existence upon the cosmic serpent Ananta, they grappled with questions of creation and infinity that still occupy physicists today. The ancients didn't separate the how from the why, and in that unity they found something we've since lost, a cosmos that was not only comprehensible but deeply meaningful. In the end, these myths endure not because they were wrong, but because they were right in ways that transcend facts. They recognized that the universe is more than a clockwork mechanism, it's a story, ever unfolding, and we are both its readers and its characters. The constellations our ancestors named still guide spacecraft today, proving that even in our age of quantum physics and dark matter, we still navigate by the stars of human imagination. The myths may have faded, but the wonder they encoded still lights our way, a reminder that every scientific truth begins with a question, and sometimes the best answers come wrapped in poetry. Archaeoastronomy unveils a world where stone and sky were inseparable, where the ancients didn't just observe the stars, but etched their knowledge into the very landscape. Take Stonehenge, that enigmatic ring of standing stones on England's Salisbury Plain. For centuries, it was dismissed as a primitive temple until researchers noticed something extraordinary. At dawn on the summer solstice, the sun's first rays slice perfectly between the heel stone and into the heart of the circle, illuminating the altar like a celestial spotlight. This wasn't accidental. The builders aligned the entire monument to capture this moment, turning stone into a solar calendar that marked the year's longest day with theatrical precision. But Stonehenge isn't alone in this cosmic conversation. Halfway across the world, the Great Pyramid of Giza whispers its own astronomical secrets. Its four sides align almost perfectly with the cardinal directions north, south, east, and west, with an error margin smaller than 1/10 of a degree. How did the Egyptians achieve such accuracy without compasses or satellites? Scholars suspect they used the stars, perhaps tracking the circular path of a single star around the celestial pole to find true north. Even more tantalizing is the so-called Orion correlation theory, which suggests the pyramid's air shafts point directly to Orion's belt at specific times, mirroring the constellation's position in the sky when the pyramid was built. Whether coincidence or intentional, the alignment reflects a culture that saw the pharaoh's afterlife as a celestial journey, his soul ascending to join the eternal stars. Then there are the Nazca lines, those colossal geoglyphs carved into Peru's desert floor. From the ground, they're mere scratches in the earth, but from above, they reveal sprawling figures: a hummingbird, a spider, a whale visible only from the heights where gods might dwell. Some researchers argue these aren't just art but astronomical maps. The straight lines might track the rising and setting of the sun during solstices, while the animal shapes could represent constellations important to Nazca cosmology. The astronaut glyph, with its wide eyes pointing skyward, even hints at a fascination with celestial visitors. Whether the lines were pilgrimage paths, ritual spaces, or star charts, their scale suggests the Nazca saw the desert as a canvas for cosmic dialogue. What ties these sites together isn't just their precision but their purpose. Newgrange in Ireland, a tomb older than the pyramids, floods with light for 17 minutes at winter solstice sunrise, a fleeting rebirth of warmth in the year's darkest days. Chaco Canyon's Pueblo Bonito in New Mexico has petroglyphs that mark lunar standstills, events occurring only every 18.6 years. And at Angkor Wat in Cambodia, the temple's western gate aligns with the spring equinox sun, a symbol of balance between heaven and earth. These weren't just buildings, they were timekeepers, calendars, and bridges to the divine, designed to synchronize human life with celestial rhythms. The brilliance of archaeoastronomy lies in its revelation that ancient skywatchers were far more than stargazers. They were architects of time itself. Without telescopes or written records, they encoded astronomical knowledge into landscapes, turning mountains, stones, and deserts into permanent observatories. Their monuments remind us that the sky wasn't just something they looked at. It was something they lived by: a clock, a compass, and a scripture written in light. In an age before artificial illumination, the stars were their streetlights, the moon their calendar, and the solstices their national holidays. To study these alignments isn't just to uncover lost science. It's to hear the whispers of cultures who saw the universe not as separate from humanity, but as its most profound teacher. The flames that consumed the Library of Alexandria didn't just burn parchment and ink, they devoured entire worlds of cosmic understanding. Among its lost treasures were the works of Aristarchus of Samos, who proposed a heliocentric solar system 17 centuries before Copernicus, and Eratosthenes, who calculated Earth's circumference with astonishing accuracy using nothing but shadows and geometry. These weren't just books, they were windows into a scientific tradition far more advanced than we once believed. The library's destruction wasn't merely a historical tragedy, it was a cosmic blackout, severing our connection to ideas that might have changed the course of astronomy. Then there's the Antikythera mechanism, a corroded bronze artifact hauled from a shipwreck in 1901. At first glance, it resembled a lump of coral-encrusted junk. until X-rays revealed gears within gears, a labyrinth of precision engineering that tracked the moon's phases, predicted eclipses, and even modeled the irregular orbit of planets. This wasn't just a calendar, it was a miniature cosmos in a box, a level of mechanical sophistication unmatched until the Renaissance. The terrifying question it raises, how many other devices like this existed? Were there star charts etched on silver plates, celestial globes with moving constellations, or even early telescopes lost to time? The Antikythera hints at a Hellenistic world buzzing with technologies we've barely begun to imagine. Consider the Baghdad Observatory's fate. In the 13th century, Nasir al-Din al-Tusi designed instruments that are so precise they inspired Copernicus's math, yet Mongol invaders reduced its archives to ashes. Or the Maya's Dresden Codex, one of only 4 surviving bark paper books, which contains Venus tables accurate to within 2 hours over 500 years. What other codices filled with eclipse cycles or comet records turned to dust in humid jungles? Even China's imperial astronomers, who documented supernova and sunspots for millennia, saw their earliest records vanish in the Qin dynasty's book burnings. These gaps aren't just historical curiosities, they're missing puzzle pieces in humanity's quest to understand the universe. When the Spanish burned Mayan texts as heathen nonsense, they may have destroyed observations of celestial events modern astronomers would kill to study. The gnawing truth is this: every fire, every conquest, every act of censorship didn't just erase words, it erased whole ways of seeing the cosmos. We're left reconstructing ancient knowledge from fragments, like trying to map the night sky using only a handful of surviving stars. Yet there's hope in the shadows. Modern technology is uncovering lost texts through multispectral imaging, revealing erased star charts beneath medieval manuscripts. Archaeologists sift through Egyptian rubbish heaps for astronomical ostraca pottery shards where scribes practiced celestial math. Even the Antikythera's secrets are still emerging, with recent scans exposing hidden inscriptions about planetary motion. Each discovery whispers the same tantalizing promise: the past might still have cosmic lessons to teach us. The ancients weren't just stargazers, they were scientists, engineers, and philosophers whose lost wisdom could hold keys to mysteries we've yet to solve. Their silence isn't empty, it's an invitation to listen harder. Cosmic symbolism didn't just decorate ancient buildings, it shaped them from the ground up, turning stone into star maps and mortar into mythology. Walk through the ruins of a Mayan city like Tikal, and you're not just seeing pyramids, you're standing inside a 3-dimensional calendar. The Temple of the Great Jaguar rises 9 step levels high, representing the 9 layers of the underworld from Mayan cosmology, while its rooftop shrine aligns with the sun during equinoxes, casting shadows that slither down the stairs like the serpent god Kukulkan descending to earth. This wasn't mere ornamentation, it was sacred geometry, where every angle corresponded to celestial events and every staircase became a stairway to heaven. Half a world away, Hindu temple architects were working the same cosmic magic. The towering shikaras of Khajuraho and Konark weren't just impressive feats of engineering, they were stone replicas of Mount Meru, the axis mundi believed to connect earth, heaven, and the underworld. As worshippers moved through the temple's mandala-like layout, they weren't simply walking through rooms but symbolically journeying through the cosmos itself. The Garbhagriha, or inner sanctum, represented the universe's creative womb, while the temple's outer walls often featured carvings of the Navagraha, the 9 planetary deities that governed Hindu astrology. Even the materials spoke this celestial language. Gold-leafed spires mirrored the sun's brilliance, while black stone sanctums evoked the infinite darkness of space. The Romans took a different but equally profound approach. In the buried ruins of Pompeii's Villa of the Mysteries, a stunning mosaic zodiac floor survives, its 12 signs encircling a central sun god like planets in orbit. Wealthy Romans commissioned these cosmic floors not just to display their wealth but to align their homes with the harmony of the spheres, a belief that earthly spaces should resonate with celestial order. Meanwhile, public buildings like the Pantheon made the heavens architectural. Its oculus, that famous circular opening in the dome, acts as a celestial sundial, tracking the sun's path across the interior like a slow-motion planetarium show. On April 21st, Rome's founding date, sunlight streams directly through the oculus to illuminate the entrance in a golden blast, merging civic pride with solar worship. Even prehistoric cultures left their mark on this cosmic canvas. The passage tomb of Newgrange in Ireland, older than Stonehenge by 1,000 years, transforms into a cathedral of light each winter solstice. For 17 precious minutes, sunlight pierces its narrow roof-box tunnel, creeping down the 60-foot passageway to illuminate intricate spiral carvings at the chamber's heart. These triple spirals, found at sacred sites across Neolithic Europe, may represent the three realms of earth, sky, and underworld, or perhaps the eternal cycle of life, death, and rebirth mirrored in the stars' endless dance. What unites these traditions across continents and millennia is their recognition of architecture as alchemy, the art of turning physical spaces into portals. Whether it's the Islamic world's Muqarnas vaulting, designed to resemble the starry firmament, or the Hopi kivas with their Sipapu holes symbolizing the people's emergence from the underworld, sacred buildings have always served as bridges between realms. The next time you gaze up at a cathedral's vaulted ceiling or stroll through a temple's shadowed halls, remember, you're not just looking at a building, but at someone's attempt to hold infinity in their hands, to carve the universe's mystery into something you can touch. The night sky was never just a map of stars for ancient philosophers. It was a mirror reflecting humanity's deepest questions about meaning and belonging. When Greek thinkers like Heraclitus spoke of the Logos, they weren't describing a mere cosmic principle, but an intelligent fire that animated all things, connecting human reason with the very fabric of reality. This wasn't abstract speculation. It was the birth of Western science's foundational belief that the universe operates by discernible laws, and that the human mind might comprehend them. The same impulse drove Hindu sages to meditate on Brahman, the ultimate reality beyond names and forms, where individual souls and swirling galaxies alike were seen as waves on a single boundless ocean of consciousness. Their cosmological hymns in the Upanishads didn't separate astronomy from spirituality. The same breath that described the sun's path also asked, "Who am I?" Chinese sages approached these mysteries differently but no less profoundly. The Tao, symbolized by the swirling yin-yang, represented the harmonious flow underlying apparent chaos, the way planets move without clocks, the way seasons change without command. Where Greek philosophy often sought to conquer nature through reason and Hindu thought sought union with the divine, Taoist astronomers like Zhang Heng watched the heavens with the patience of water wearing down stone, understanding celestial patterns as expressions of an organic, self-regulating whole. His famous seismoscope, shaped like a celestial sphere with 8 dragon heads representing directions, didn't just predict earthquakes, it embodied the interconnectedness of heaven, earth, and humanity. What unites these traditions is their refusal to see the cosmos as indifferent. The Mayan Popol Vuh declares humans were made from maize and stardust so we might keep the days, not just count them, but steward time itself as sacred participants. Egyptian pyramid texts describe the dead pharaoh becoming one with Orion, his earthly rule transitioning to celestial governance. Even the Norse, whose mythology brims with apocalyptic fire and ice, envisioned the world tree Yggdrasil sustaining all realms, its roots in the underworld, its branches cradling Asgard, and its leaves whispering with the winds of destiny. Modern astrophysics tells us we're made of supernova debris, that our atoms were forged in dying stars. The ancients knew this truth intuitively when they wove human fate into cosmic narratives. Their real genius wasn't in precise calculations, though many were remarkably accurate, but in recognizing that astronomy, divorced from philosophy, leaves us stranded in a vast, silent universe. When Ptolemy mapped epicycles and Indian astronomers calculated Earth's circumference, they weren't just solving puzzles, they were seeking the same answers that keep astrophysicists awake today. Does the universe have a purpose? Are we its intended witnesses or accidental specks? The most radical idea ancient cosmologies offer isn't about celestial mechanics but perspective. Indigenous star lore from Australia to the Arctic insists the sky isn't something we observe but something we belong to, that human stories and stellar phenomena are threads in the same tapestry. A Cherokee elder tracking the Pleiades rise to time the green corn ceremony, a Babylonian priest noting Venus's phases to predict harvests. Both were practicing science as communion, knowledge as relationship. This worldview challenges the modern dichotomy between observer and observed, suggesting that to truly know the stars, we must also let them know us. Perhaps that's why these ancient questions still resonate. When we peer through telescopes at distant galaxies or pass quantum foam's probabilities, we're continuing dialogues begun in shadowed caves and torchlit temples. The medium has changed. Equations replace epic poems. Supercomputers model what shamans once envisioned, but the essential wonder remains. The cosmos whispers to us as it did to them, not in answers but in invitations, to look up, to ponder, to recognize that every astronomical discovery is also a step toward understanding what it means to be alive in such a strange and splendid universe. Imagine standing in the Egyptian desert 3,000 years ago, armed with nothing but a stick and a string. This simple tool, the gnomon, was the first step in humanity's quest to measure the heavens. Planted vertically in the sand, its shadow became a cosmic clock hand, tracing the sun's path with uncanny precision. At noon, when the shadow aligned perfectly north, the Egyptians could determine true solar time, and by tracking the shadow's shortest and longest lengths across seasons, they marked solstices with an accuracy rivaling modern instruments. The gnomon wasn't just a sundial, it was a bridge between earth and sky, transforming sunlight into knowledge, but precision demanded more than shadows. Enter the Merkit, an ingenious device resembling a plumb line with a sighting tool. Egyptian astronomers used pairs of these to align with specific stars, creating a celestial meridian, an invisible north-south line in the sky. By watching a star cross this line, they could measure night hours with startling accuracy. The Great Pyramid's near-perfect cardinal alignment likely owes its precision to these tools, proving that ancient skywatchers didn't just observe the cosmos, they conversed with it, using geometry as their language. Half a world away, the Dogon people of Mali demonstrated another kind of astronomical brilliance. Without telescopes, they knew Sirius, the brightest star in our sky, had an invisible companion, Sirius B, a white dwarf so dense its discovery in 1862 stunned modern astronomers. Dogon oral traditions described its 50-year orbit and even its density, calling it Po-Tolo, the smallest and heaviest thing. How some suggest ancient contact with advanced civilizations, others argue millennia of meticulous observation passed down through generations. Their knowledge hints at a universal truth. The naked eye, when trained by patience and tradition, can uncover secrets we assume require technology. The astrolabe, perfected by Islamic scholars, took celestial measurement to new heights. This handheld brass marvel, often called the smartphone of the Middle Ages, could calculate star positions, tell time, and even determine prayer directions. By rotating its pierced discs, each representing celestial spheres, users could simulate the sky's motion for any date or latitude. Chaucer wrote an instruction manual for it. Ships carried it across oceans. Its beauty lay in its duality, a tool for both navigation and contemplation, blending math with poetry. What unites these techniques is their reliance on pattern recognition. Ancient astronomers didn't just record events, they lived them, watching the same stars rise generation after generation until celestial rhythms became second nature. Stone circles like Nabta in Egypt, predating Stonehenge by 1,000 years, align with solstice sunrises and the Milky Way's brightest regions. Chinese astronomers etched comet sightings onto oracle bones, creating the oldest surviving records of Halley's Comet. The Maya tracked Venus's cycles with such precision their calculations were off by just 2 hours over 5 centuries. Reconstructing these methods today isn't just historical curiosity, it's a masterclass in attention. Modern telescopes peer deeper into space, but ancient skywatchers peered deeper into time, noticing subtleties we might overlook. The slight wobble in a star's position, the faintest shift in a planet's hue. Their legacy reminds us that astronomy began not with lenses, but with lifetimes of watching, wondering, and weaving the heavens into the fabric of daily life. The night sky was their classroom, and their lesson was clear. To know the cosmos, you must first learn to see. The idea of a multiverse, countless parallel realities coexisting like bubbles in an infinite cosmic foam, seems like the cutting edge of modern physics. Yet this concept would feel eerily familiar to a Hindu sage from 3,000 years ago. Ancient Vedic texts describe innumerable Brahmandas, or cosmic eggs, each with its own laws and timelines, floating in the causal ocean of existence. Buddhist cosmology goes further, envisioning infinite world systems rising and dissolving in cycles so vast they make our 13.8 billion-year-old universe seem like a blink. These weren't poetic metaphors but sophisticated models of reality, born from deep meditation and observation. Today, when physicists like Brian Greene talk about the landscape of string theory, where every possible universe configuration exists somewhere in the quantum foam, they're walking a path first mapped by ancient mystics. Equally striking are the echoes between Plato's realm of perfect forms and modern theories of higher dimensions. The Greek philosopher imagined a hidden world of ideal shapes, the true circle beyond all flawed earthly copies existing in a transcendent space. Fast forward to today's string theory, which posits 10 or 11 dimensions curled into scales too tiny to perceive, where the fundamental strings of reality vibrate in geometric perfection. Even the holographic principle, suggesting our three-dimensional universe might be a projection from a two-dimensional boundary, mirrors the allegory of Plato's cave, where shadows on a wall were the only reality prisoners knew. The tools have changed, equations replace allegories, particle accelerators supplant introspection, but the intuition remains that what we see is only a fragment of a far richer reality. Then there's the Big Bang, often framed as science's answer to creation myths. But look closer and you'll find uncanny resemblances. The Babylonian Enuma Elish describes a universe born from the mingling of primordial waters, Apsu and Tiamat, a poetic parallel to quantum fluctuations in the pre-Big Bang vacuum. The Aboriginal Australian concept of the dream time, where the world emerges from a timeless, formless state, aligns with modern cosmology's idea of space-time crystallizing from an earlier phase. Even the biblical "let there be light" finds a scientific counterpart in the cosmic microwave background, the afterglow of the universe's first luminous moments. These parallels don't mean ancient cultures predicted modern physics. Rather, they reveal how human minds, when grappling with ultimate questions, often arrive at similar metaphors: water, eggs, breath, to describe the indescribable. What's most humbling is how ancient stargazers anticipated challenges we're only now confronting. The Mayas' obsession with cyclical time resonates with today's theories of eternal inflation, where universes sprout from one another endlessly. The Norse myth of Yggdrasil, the world tree connecting realms, feels oddly prescient of dark matter's cosmic web, the invisible scaffolding that binds galaxies together. And when quantum physicists speak of particles being simultaneously here and there, they echo the Aboriginal understanding of the everyone, where past, present, and future coexist. This legacy isn't about crediting ancients with knowledge they didn't possess. It's about recognizing that science and myth are two dialects of the same longing. One quantifies, the other qualifies. One measures, the other marvels. Perhaps that's why so many pioneering scientists, from Kepler to Einstein, drew inspiration from spiritual traditions. They understood that discovery requires not just data, but daring the courage to imagine realities beyond sensory proof. The next time you hear about dark energy or multiverses, remember, you're witnessing the latest chapter in humanity's oldest conversation, one that began when the first storytellers looked up and saw not just stars, but stories waiting to be told. From the star myths of Egypt to the quantum mysteries of today, humanity's conception of the universe has always been a blend of observation, imagination, and awe. The ancients may not have had telescopes, but their cosmologies were no less profound, offering insights that still resonate. Think of the Egyptian priest astronomers who aligned pyramids to Orion's belt, or the Mayan mathematicians whose Venus tables rival modern algorithms. These weren't primitive guesses, they were sophisticated attempts to decode a universe that, even today, defies full comprehension. What's remarkable isn't how much they got wrong, but how often they glimpsed truths we've only recently confirmed with supercomputers and satellites. Consider the parallels between their visions and ours. The Hindu concept of infinite, cyclical universes mirrors modern multiverse theories. The Aboriginal dream time, where past and future coexist, finds echoes in quantum physics' timeless equations. Even the Greek atomists dreaming of indivisible particles foreshadowed the quark and lepton. These weren't lucky strikes, they were the fruits of deep attention, of generations watching the same stars rise, tracking the same planetary loops, and asking the same relentless questions. The tools have changed, but the wonder remains. Modern astrophysics has expanded the stage, yet the play feels familiar. Dark matter's invisible grip on galaxies recalls the Maori's belief in unseen forces binding the cosmos. The cosmic web of galaxies mirrors Yggdrasil, the Norse world tree threading through realms. Even the Big Bang's fiery birth finds its counterpart in creation myths, from the Navajo to the Dogon, where light emerges from primordial darkness. Science has given us sharper lenses, but the fundamental mysteries endure. Why is there something rather than nothing? Are we alone? What lies beyond the horizon of our understanding? Perhaps the greatest lesson from ancient cosmologies is their humility. They saw the universe not as a puzzle to be solved, but as a story to be lived, a narrative where humanity played a role, however small. In our age of exoplanet discoveries and quantum entanglement, that perspective still holds power. The James Webb Telescope's infrared eyes may peer further than Babylonian ziggurats ever could, but both reveal the same truth. The universe is vaster, stranger, and more interconnected than we imagined. So keep looking up, not just with telescopes, but with the same blend of curiosity and reverence that guided the first stargazers. The cosmos they charted in myth and mathematics is the one we explore today, a story written in light and time, waiting for each generation to add its chapter. The universe remains as it always was, beyond imagination, and that's the most thrilling discovery.